add the polynomials. The first polynomial is 4x to the 6th plus 2x to the 5th plus 2. To this first polynomial, we're adding second polynomial of 3x to the 6th minus 7x to the 5th plus 3. These are two trinomials. The trick is to add the second polynomial to the first. So we are actually looking like at the concept of like terms. The way we identify like terms, we first start over in the first polynomial and we say, here's a term that's got an x to the 6th. Do we have in the second polynomial, do we have a term that's got an x to the 6th in it? And we say yes. Since we're adding two polynomials together, we take this like term and identify where it goes. I'm lining up for vertical addition. I'm saying this second polynomial has an x to the 6th term in it. I'm lining up with this like term in the first polynomial, and then I go back and grab its coefficient, the number part. I go, that guy in the second polynomial is a 3x to the 6th. So here we are. We're ready to add those together. But I'm going to do this to all of them. Look, this term moved over vertically underneath its like term in the first polynomial. So I scratch this guy out. Then we move on. We say in this first polynomial we have a term that's an x to the 5th power. Like terms, you know, like we did in the first one, first pair of like terms, have the same variable and the same exponent. So we find that there is a like term that has an x to the 5th in the second polynomial. What we do is say there is another term that's an x to the 5th term. So now I come over, I located it, I put a place marker for x to the 5th, and now I bring over the -7. It's just my own way of identifying. I put a place marker with the x to the 5th and then come back and grab its coefficient. I slash this out because it appears over here now. The -7x to the 5th appears over underneath its like term in the first polynomial. I'm just thinking in columns. Here's a constant. Is there a constant in common? It has a like term in the second polynomial? Yes, it does. We're going to move this guy over underneath its like term in the first polynomial and slash it out because it appears here now vertically. We're ready for vertical addition. So now when we actually add these together, I'm just going to change the pen color here. What we find is, you know, when we're adding like terms, and I'm just thinking of addition now, x to the 6th plus x to the 6th would remain x to the 6th. When we're adding and subtracting variable terms, we don't change the exponent. The exponent stays the same. Now I can think money. When you think about addition, you can think that positive numbers is like having $4. Positive numbers are having money. Negative numbers are like owing money. So if I have $4 in one pocket, I have $3 in the other pocket, I have a total of $7. It works like that for the coefficient. Move on to the next set of terms. X to the 5th plus or minus x to the 5th remains x to the 5th. We're just making sure the exponent on the variable doesn't change. In this case, I have $2, but I owe somebody $7. If I owe somebody more than I have, the result, my net worth is going to be negative. I owe more than I have, so when I pay this person back all the $2 that I have, I still end up owing that person $5. That's the gimmick that we use, or we can use without a calculator. Here is simple addition. Positive 2 plus 3 is positive 5. When we clean this answer up, removing all the unnecessary symbols, which is really just the leading positive sign, we arrive at the final correct answer. We go and look at it. If I was to mark a Scantron sheet or click it on a screen, when I compare all these carefully, C appears to be the only correct answer when I look at each component of the answer and compare it to the answer that we got. Make the correct response.